Subject is Computer Architecture and Organization, Unit number 5, Multiprocessor, Lecture number 3. What is the multiprocessor? The basic topic is Introduction and Characteristics of Multiprocessor, Interconnection Structure, Interprocessor Arbitration, Interprocessor Communication and Synchronization, Case Coherence. Introduction. A multiprocessor system is an interconnection of two or more CPU with memory and input-output equipment. Second, IOP, it means input-output processor are generally not included in the definition of multiprocessor system unless they have computational facilities comparable to CPU. Three, multiprocessor are MIMD system. MIMD means multiple instruction, multiple data stream. Fourth, multi-computer system includes number of computers connected together by means of communication lines. It is improved reliability. If one system fails, the whole system continues to function with perhaps low efficiency. Or last, the computational can process in parallel in two ways. Number one, multiple independent jobs operate in parallel. Second, a single job can be partitioned into multiple parallel tasks. Multiple processors are classified by the way their memory is organized. Shared memory or tightly coupled multiprocessor. Second, distributed memory and loosely coupled multiprocessor. These topics are discussed in previous slide, lecture number 2. Interconnection structure. We also discuss this topic in previous slide, lecture number 2. In this slide, we discuss in brief the component that forms the multiprocessor system are number 1 CPU, number 2 IOP, input output processor, input output device, it means peripheral device, and last memory. Physical form available for establishing an interconnection network are time shared common bus and multi-port memory. Crossbar switches, multi-stage switching network, hypercube system. Interprocessor arbitration. Computer system contains a number of buses at various levels to facilitate the transfer of information. A bus that connects major component in a multiprocessor system such as CPU, IOP and memory is called system bus. Arbitration logic is the part of system bus controller placed between local bus and system bus that resolve the multiple contention for shared resource. A typical system consists of approximately 100 signals line. These lines are divided into three functions group: data, address and control. It means data lines, address lines and control lines. In addition, there are power distribution lines that supply power to the component. For example, IEEE standard 796 multi-buses system has 16 data lines, 24 address line, 26 control line and 20 power lines for total of 86 lines. Data lines provide a path for the transfer of data between processor and common memory. The number of data lines are usually multiple of 8, with 16 and 32 being most common. Third, address lines are used to identify memory location or any other source and destination units. The number of address lines determine the maximum possible memory capacity in the system. Last, the control lines provide signal for controlling information. Time signal indicate validity of data and address. Command signal specify the operation to be performed. Data transfer on the system can be synchronous and asynchronous. Arbitration procedure. What is the procedure? The arbitration procedure serves all processor requests on the basis of established priorities. It can be implemented in two ways: serial connection of unit and parallel connection of unit. Serial arbitration procedure. It is obtained from daisy chain connection of bus arbitration circuit similar to the case of priority interrupt. Each bus has its own arbiter logic which are arranged according to the priorities from highest to the lowest. This is the diagram. Serial arbitration is mean daisy chain arbitration. There are four devices: arbiter first, arbiter second, arbiter third, and arbiter 4. It according to highest priority to lowest priority. These are the connected by the bus. Parallel arbitration logic. It use an external priority encoder and decoder. Each bus arbiter has a bus request output lines and a bus acknowledge input lines. Each arbiter enable request line when its processor is requesting the system bus. Last, the one with highest priority determined by the output of the decoder get access to the bus. This is the example. Dynamic arbiter algorithm. Serial and parallel bus arbitration are static since the priorities assigned is fixed. In dynamic arbitration, priority of the system change while the system is in operation. The various algorithms used are time slice, polling, least recently used, LRU, first in the first out, rotating daisy chain. Interprocess communication. All the processors in the multiprocessor system need to communicate with each other. The most common way is to set aside portion of memory that is accessible to all processor. Sending processor puts the data and the address of the receiving processor in the memory. All the processor periodically check the memory for any information. If they find their address, they read the data. This procedure is time consuming. Another procedure is to send the interrupt signal to the receive process whenever the sending process leaves the message. In addition to shared memory, multiprocessor system may have other shared resources. To prevent the conflicting use of shared resource by several processors, there must be provision for assigning resource to the processor. This task is handled by the operating system. There are three organizations that have been used in designing the operating system of multiprocessor: master slave configuration, separate OS, and distributed OS. The master slave configuration: one processor designated as master execute OS function. If slave processor need OS service, it must request to the master processor. In separate OS configuration, each processor can execute the OS routine it needed. This organization is suited for loosely coupled system where every processor have its own copy of the entire OS. In distributed OS, the OS routines are distributed among the processor. Each particular OS function is assigned to only one processor at a time. Since the routines float from one processor to another, it is also called floating OS. Interprocess synchronization. What is interprocess synchronization? Synchronization is a special case of communication where data used to communicate between processors is control information. It is needed to enforce correct sequence of process that to ensure mutually exclusive access to shared writable data. A number of hardware mechanisms for mutual exclusion have been developed. One of the most popular is through the use of binary semaphore. Proper function multiprocessor should guarantee orderly access to shared resources so that data can be changed simultaneously by the two processors. This is called mutual exclusion. Mutual exclusion must be provided in multiprocessor to enable one processor to lock out access to shared resources when it entered in critical section. Critical section means is a program sequence that must be completed once begun. A semaphore can be initialized by mean to test and set instruction in conjunction with the hardware lock mechanism. A hardware lock is processor generated signal that prevent other processor from using system bus as long as signal is active. Test and set instruction set test and set semaphore and active lock mechanism during the time that it is testing and setting it. Cache coherence. In shared memory, multiprocessor system processors share memory and they have lock memory. To ensure ability of the system to execute memory instruction independently, multiple copies of the data must be identical, which is called cache coherence. Condition to incoherence. This condition arises when the processor needs to share the writable data. In both policy write back and write through, incoherence condition is created. In case of DMA also, IOP, input output processor, modifies the data in main memory which reside in the cache and cannot be. Thank you. Next slide we discuss the shared memory.